Today we will see in detail the Klein-Gordon relativistic equation. Before that, we will see what is the problem with the Schrödinger equation. The Schrödinger equation fails for relativistic particle that we are going to see now. The Schrödinger equation is based on the non-relativistic approximation. E is approximately equal to p squared over 2m plus V. First term is kinetic energy and second one is potential energy. But in special relativity, the exact relation is E squared is equal to P squared C squared plus M squared C power 4 at high velocity, that is the velocity of particle is close to velocity of light, the non-relativistic approximation breakdown, this equation breakdowns. So Schrödinger equation cannot describe the particle moving close to speed of light. So this is the problem with the Schrödinger wave equation in the case of relativistic approximation. The another problem with the Schrödinger equation is its lack of Lorentz invariance. You know the what is Lorentz invariance? That the physics does not change if you do the Lorentz transformation. So the uh, physics of system particle is independent of the framework. So the Schrödinger equation is first order in time, but second order in space. So the time space are treated differently. That is, the Schrödinger equation is I h cross delta over delta t psi, which is equal to minus h cross squared over 2m del squared psi, where del squared is a Laplacian operator, plus v psi. So here you can see with respect to time is first order derivative, with respect to space it is a second order derivative. But here what advantage is, since is first order in time, if you know the initial value, you can find the value of the wave function at any other time. That is one advantage. But disadvantage is there is no symmetry. This is first order time derivative and the second order spatial derivative. The relativity demands that phase and time must be treated on equal footing. That is a Lorentz symmetry. So hence Schrödinger equation is not Lorentz invariant. Now we will derive the Klein-Gordon equation in a very simple manner. We know the relativistic Schrödinger equation is E squared is equal to P squared C squared plus M squared C power 4. Now you replace this energy and momentum by its operator. E square operator. Energy operator is I h cross delta over delta t. And then E squared operator is just to square it. Similarly, here momentum operator C squared I am keeping as it is. Momentum I am replacing by its momentum squared operator. That is momentum operator is minus I h cross delta. So if you square it, you will get minus I h cross del whole squared psi plus m squared c power 4 psi. So just you square it. If you square it, you will get minus h cross squared delta 2 over delta t2 psi. In the right hand side, c squared I am keeping as it is. Minus I squared, you will become minus minus 1, like here I squared is minus 1. So naturally this minus, when you square it, it will become plus, only the I squared will become minus 1. So you have c squared h cross squared del squared psi plus m squared c power 4 psi. Now you divide this by h cross squared c, both right hand side and left hand side. So if you do it in the right hand side, you will get minus 1 over c squared uh, delta 2 over delta t to psi. Then here this will go away. H cross squared c squared will go away. You will get only minus del squared psi. And here you will get h cross squared c squared. If you divide, this will become a c squared. C power 4 will become c squared. So now I have divided by h cross squared c squared and drop this psi wave function and rearrange. Rearrange means you bring the left hand side term to the right hand side. This minus will become plus. So you take the positive term first. 1 over c squared delta, because when you bring this other side, your minus will become plus. 1 over c squared delta 2 over delta t2. And here you have minus delta squared. Here m square c squared over h cross squared multiplied by psi, which is equal to 0. The above equation is called Klein-Gordon equation. Now we will see the energy eigenvalue of Klein-Gordon equation. Uh, Before rearrangement of Klein-Gordon equation, we have seen that I h cross delta over delta t whole square is equal to c squared minus, this is momentum operator. Square of the momentum operator is minus I h cross squared del squared psi plus m squared c power 4. So now here when energy operator act on psi, it will produce the energy, eigenvalue energy multiplied by psi. Now we are going to drop this psi. So naturally the eigenvalue in the left hand side is h cross squared omega squared. Uh, what about right hand side? When momentum operator act on psi, we will get momentum eigenvalue, eigenvalue p. That is, p is h cross k in quantum mechanics. So if you square it, you will get h cross squared, k squared, already one c squared is there. Of course, we are dropping this wave function psi. Then same thing, m squared c power 4, and we have dropped this psi. Then what about the energy h cross omega is equal to, you take the square root, it may be plus or minus square root of h cross squared k squared c squared plus m squared c power 4. This means that the energy eigenvalue can have both positive and negative value. So here you can have a negative value, maybe due to antiparticle, that we will see later. So we will see about the Lorentz invariance of Klein-Gordon equation. The relativistic Klein-Gordon equation is, we have seen just now, 1 over c squared delta 2 over delta t2 minus del squared plus m squared c squared over h cross squared multiplied by psi, which is equal to 0. The Klein-Gordon relativistic wave equation is for spin equal to 0. So this is for zero spin. We have not considered the spin right now. We will do it when we are dealing with Dirac relativistic equation. It is second order in time, unlike Schrödinger equation, which is first order in time. The existence of a negative energy solution leads to natural to the concept of antiparticle. A consistent probabilistic interpretation required quantum field theory. For spin of particle, one uses the Dirac relativistic equation. So we will see that later stage. And now we will see the probability density of Klein-Gordon equation. From the continuity equation, we know the probability density is equal to I h cross over 2 m c squared psi star, the first order time derivative of psi minus psi first order time derivative of psi star. So this can be written as you bring this IH cross inside the bracket. Inside, you bring this in fourth term, of course. In fourth term, you bring this. This will become, first term will become psi star IH cross delta over delta T psi. So the second term, what about the second term? Second term is psi. Here, I have, if you take complex conjugate, because a complex conjugate will come first. So the IH cross will become minus IH cross. There is already one minus. So this will become plus psi IH cross delta over delta T. Then what will happen if energy operator act on psi? You will get E psi. Similarly, if energy operator act on psi star, you will get E psi star. So here you can see in the first term and the second term you have E. E is a number, you can take it out. So the probability density is equal to E over mc squared psi star psi. So the equation admit is solution with negative energy. So this one, which leads to instability and unphysical interpretation in single particle quantum mechanics. That is, you cannot have negative probability. But we have shown that there is a possibility of energy is having negative energy. Unlike a Schrödinger equation, which is first order in time, the Klein-Gordon is second order in time. That is very so, as I said earlier, this complicates the initial value problem. That is, in the case of Schrödinger wave equation, since it is a first order time derivative, if you know the initial wave function, you can find the wave function at any other time, which is very much complicated. This in the case of Klein-Gordon equation. If this lecture is helpful to you, kindly like it and also subscribe it in order to get updated my videos, new videos update. Also, join my channel for the growth of my channel. Thank you very much for watching my video and supporting me continuously. Thank you very much.